So now we're going to cover strings. So strings are sequential collections of 0 or more letters. Let me go ahead and create one here. And whenever you use a string in Python as literal information, you have to put it in quotes. So I'm going to make a string David. And you can include anything you can type on the keyboard. Strings actually store Unicode. So basically you can put in any language as well. Strings also allow you to input as single quotes or double quotes, and they behave exactly the same. So it's entirely up to you. As long as if you start with a single quote, you have to end with a single quote, and the same with the double quotes. Strings can also have the backslash characters you see in C++. And I'm going to assign that to a variable. And so we've made a string that has Dave, a new line character, Tom, a new line character, and Sally. And I'm going to print that, which behaves a little bit different than just showing it in idle. And you'll see it prints out as 3 lines. If I just do S1 in idle, it basically brings it back as how you would type it in. And that's what idle normally does, is put it in what it would look like as a literal in Python. Okay, you can also index into a string. So I can say S1 index number 4. And that should be the backslash actually. And you can say S1 index 5, and that should be the T in Tom. But you can't do assignment. Strings are considered immutable. So once you create them, you can't modify them. You can only make a new string and then set S1 to point to the new string. So some of the operators that work on sequences also work on string. So if I want to repeat this 3 times, I can multiply it by 3, and it makes it concatenates it all together. You can use plus for concatenation. And it puts them together. And you can also get the length of a string using the length operator. So it gives us the length of the string, including all the spaces and new line characters. Some other things you can do is there are methods for strings. So you can do upper. So s1.upper. So this is a method. So you have the data, the object you want to work on, dot, and then the method that's going to affect that object. I hit enter, and it returns a new string, and it's uppercased all the letters. There is a one called center. So I can say s1 dot. Well, let's not do. Let's do hello dot center, and let's center it in a 20 column wide space. Oops. I spelled center wrong. Left off the T. S1 20. And you'll notice it makes a new string, and it adds spaces to left or right to center that string. And originally we wanted to do hello dot center 20. And there it goes. So it centers hello. So you can use center to format a bunch of strings that fit in a certain column by adding extra spaces. And then there's the split command. Let's go back to David. So I'm going to set S1 equal to David. And then I'm going to say S1 dot split at the V. So what this looks for is it looks for a match to V, and where it sees a V, it's going to split this up and form a list. So what it did is it took the DA and IV and made them new elements in a list. Now this is really useful if you get input from a user. Suppose we have input from a user that's a list of names. When you get input from a user, it just comes as one big string. So I have Tom, Sally, Willie, John, Sam. So if I have a bunch of names separated by spaces or commas, this is really useful to split them up. So what you do is you say s2 dot split, and you want to split everywhere you see a space. So you put a string in for a space, hit enter, and now it's made a list of all those names. So you can get you can basically build an array of all the names, splitting it up on the space. So that's what split does. Now here's a summary of these. So you have center, we have count, which will count the number of occurrences of a string. Now this is different a little bit than the count of counting in a list, because it will match a longer string than just individual letters. So if I can demonstrate that, so let's set S3 equal to, let's see, AB, hello, AB, and CD, AB. So you can see AB shows up several times. So I can say S3.count AB, and what it's doing, it's looking for how many times do I find the pattern AB. Well, that didn't work. Oh, wrong string. S3.count AB, and it says 3 times. There we go. So S3 was the string I wanted to really search. So that's count. Now L-just and R-just are like the column, but they create a column that puts the string all the way to the left or right. Lower is like upper, which we just used, so it returns a string of all lowercase. Find is similar to index, but it finds a substring. So it searches the string for a substring and returns the index of the first occurrence. So in this AB, hello, AB, and CD, let's search for CD. So we can say S3.find CD, and it finds it at position 16, index 16. So if we do, and you can do slices on strings. So if I say S3 slice from 16 to the end of the string, it starts at CD and gives to the end of the string. So we've covered all these methods. Now the major difference between list and strings is that lists can be modified while strings cannot. And this, it points out, I mentioned earlier, this is called the mutability. So lists are mutable, strings are immutable. So you can change an item in a list by indexing an assignment, but with a string it's not allowed. And so he shows you that here. And that's a little short segment on strings.